6 parts into our graphics programming series using C on macOS, we are going to finally build something useful. We'll do this clock here. The first part is application structure. Then we will look into platform services, make the renderer more generic, and then we need to implement transparency. The clock uses 4 resources: the background, hours and minutes hand, and this little knob. In terms of application structure, we are going to separate this out into our own file. So we will have a header defining the struct holding all the members we need. In this case, we need some kind of a reference to a renderer. That's going to be this void star. And we need to have the background image first because we implemented this already in the last episode. In terms of our API, the clock app has a load, an update, and a render function. The implementation of the clock app needs to have 2 includes, obviously the clock app itself and the platform services, since we need to use platform services to load images, which I showcased in the last episode. With the outline of the clock app in place, we are now going to include this into our main for our Unity build and call the load function with a clock app object created on the stack. And in our main loop, we are going to update and render the clock app. At the moment, our renderer still has like a direct reference to the clock background, but we want to have the application being responsible for knowing which images to show or not. And that's why we need some means to upload an image from the application to our renderer. And that's why we are extending our API of the platform services to include this function. A quick word on platform services. So the idea is to define platform dependent services to our application layer. Platform dependent in the sense that we are implementing this on macOS in our case, but all the API can also be implemented on a different platform like Windows or Linux. The actual implementation of the platform upload image function is not going to be placed in the CPP file, but rather directly in our platform-dependent macOS renderer. So we are going ahead and copy the interface and put it into our renderer implementation here. Another thing to note is we are taking in a void star, so this could be any kind of renderer, and now we are casting it to the actual main renderer we have implemented on macOS. Now our ObjC renderer gets its own upload image function, taking in the image we are receiving from the C interface. For the most part, the upload image function is something we already have implemented. So we need a texture descriptor, we need to create an MTL texture object, and then we need to copy over the bytes from the input image into this MTL texture. One last bit is this texture ID. This is going to be a unique identifier we can use in our application layer to reference the images. Next on our agenda is to get rid of this clock background image member for the texture and rather have a container to store arbitrary textures passed in by the application. For that, we need this thing to count up unique identifiers, and we need to have a mutable array holding the actual texture objects. In the upload function, we are now inserting the newly created texture into this mutable array and do this at the index of this texture ID and count the index up. So that means the application now has, when it receives the texture ID back, a unique means to say, hey, I want to draw this image. Last but not least, we need to have now a place to store the texture ID coming back from the platform services. So this goes into the image struct. And here we are now uploading the background image to the renderer, which in turn makes having a member variable inside of the renderer for the background image unnecessary. That's why I can get rid of this here, as well as the load background function, the implementation as well, and the call as well. Getting back to feature parity just means now to use the mutable array of textures instead of the background, and it works. Nice. With our new platform service in place and implemented by the renderer, we can now extend out the clock app to also include hour hand, minute hand, and snob image, load the images, and upload them to the renderer. Drawing textures on the screen means to have an according geometry as well. Since we now have different sized images, we need to create geometry which fits every single image. And that means we need to adapt this create geometry function and call it inside of our upload. So now we are changing the interface here, pass in width and height, and return the MTL buffer, instead of storing this in a member variable of the renderer. Our new geometry buffer, or rectangle buffer, needs to also be stored in an array of the same dimension as the textures, such that we can use the same texture ID to reference geometry and texture at the same time. So now we are using the create geometry function inside of the upload to get back the vertex buffer and insert the new vertex buffer into the array of vertex buffers at the same index, which is the texture ID. With this done, we have now removed the need for any specific members inside of the renderer, so we can now use the generic buffers and draw, which should also work, and it does. With the current setup, the renderer now has no explicit knowledge about which textures are rendered. It just renders first in both the mutable arrays for the textures and the vertex buffers. What we are setting up here is some means to pass in texture IDs. And that also means we need another platform service, which we can call from our render function. So here I'm just initializing the number of render IDs to 0. And with this done, we are now adding another platform service to render textures. So we create the platform render image function, pass in the renderer and a texture ID. Same as before, the implementation of the render image function is not in the CPP file, but rather again in our renderer directly. So we cast the incoming renderer to the main renderer, create a internal function to render images, pass the texture ID, and implement this in a way that we put the incoming texture ID into this small array I created. It's fixed size, but yeah, for our purposes, this is good enough for now. The render function of our main renderer at this point only draws one texture. So now we can go ahead and have a small loop over all the render IDs we have received via the platform service. The uniform buffer needs to be set only once, but the vertex and fragment texture things are now specific to one, let's say, draw call. And one important detail, the number of render IDs needs to be reset to 0 so that every frame we have like a fresh list of IDs to render. And now for every texture ID in our small array of render IDs, we grab a vertex buffer and a texture and pass it to our shader. To test if everything works, we are going now into the render clock app function and call the platform service to pass a texture ID over to the renderer and make a quick test if everything works. Looks good to me, so now we can add the draw calls for the hour, minute and the small knob. Compile this and see if it works. Yes, so now we have full control in the application which textures are rendered. Looking at the result, I realized I made a small mistake in the last episode, so the pixel format for our texture should be RGBA and not BGRA. So this fixes the color problem. As mentioned in the intro, the last step is to implement and support transparency. So first we need to enable this, and then we need to specify the corresponding blend operations for the alpha channel as well as for the RGB channels, which is add. So we have additive blending. And the rest, I have to admit that this minutiae is something I sometimes forget. But yeah, in the end I got it done. So here we need to take the source alpha, I think. And the same for the source RGB blend factor. And the last bit is the target, which has the well-known 1- blend source. And with this in place, we now should have working transparency for our input textures. Well, look at that. Everything gets rendered correctly, transparency seems to work, everything is controlled by the clock application. The renderer is now generic. We have platform services to load images and to upload them to the renderer and then to the GPU. So, well, pretty good for this first part. In the second part, I will show how to position stuff correctly. So the knob needs to go to the middle, as well as the clock and the hour hand. And we obviously need to rotate things according to the current time. Until then, have a good one.